So, welcome to another episode of Beta Talk. I'd like to thank my season sponsors, who are Ultimate Renewables Supplies. So today I'm joined by Joseph Saxby and Steph Willis. If you've listened to the podcast for a long time, you'd know that Steph is one of my guest, has been a previous guest on the show, and I think she'd just come back from Canada when that was the case. They are involved in a company called Spruce. So without further ado, let's hear what Spruce is. So Joseph, you set Spruce up, so tell us all about Spruce.
Yeah, cool. Well, yeah, Nathan, super nice to be on the podcast. So I guess what we're wanting to do with Spruce is basically help heat pump installers run and grow their businesses without all the pain, hassle, and manual process that they have to deal with at the moment. So yes, specifically, Spruce is a software platform that helps installers manage the whole heat pump installation journey, from dealing with the initial inquiries, doing room by room heat loss surveys and system designs, then generating heat loss reports, design reports, wrapping them together into the quotes and proposals, and then automating all the other paperwork that they need to do before and after the installation. So yeah, I mean, but the basic idea is that by using Spruce, installers can then use their skills, experience, their expertise where it really matters, which is, as you know very well, it's providing the kind of awesome customer service that they want to do, doing really high quality installations, and ultimately growing their businesses.
So
Um,
does that come under this category of job management? So it's not just heat loss; it's job management as well, is it?
I guess we help with some of the job management on for heat pump jobs. I think very technically there are a whole bunch of job management platforms out there that people use to cover the whole range of different technologies of different things they might be installing. We actually integrate with those systems, so we kind of don't people can carry on using their existing job management systems, and then we just help out with all the heat pump specific tasks.
So, Steph, I'm assuming you got brought in because you've got good knowledge around heat loss, haven't you?
Um, yeah, exactly. I guess I've worked on heat pumps for quite a long time now, and know a fair bit about heat pumps, and yeah, just I guess like really believed in the idea of like giving installers better tooling, right? Like, I mean, it's stuff that like the work that you and Emma and Nesta did in the middle of the year. I just felt like Joe was kind of pretty on it early on with like listening to installers and figuring out what they needed, and so I wanted to get involved and help with that because just a really hard job right now, and I like
Have,
the idea of making it better.
have we held? So obviously, yeah, there's lots of chat about heat loss surveys, and even consumers are starting to sort of understand there's things called heat loss surveys, I suppose. Are there still challenges, do you think?
Around heat loss, but I mean, yeah, 100%. Uh, Plenty of challenges, and probably those challenges are like a bit different depending on experience level. So obviously, there's a bunch of heat pump engineers who are like incredibly experienced, um, know lots from you and all the community learning and like the open energy monitor stuff. Like they've learned so much and like are doing a great job of heat loss and have like learned a bunch of tips and tricks. But like as the industry expands, like very helpfully, new people are getting into the industry, and there's just like so much to learn if you're coming from that gas background about doing heat loss. There's a lot, I think, more to do around education and tooling to really like help people do a good job of heat loss.
Totally. And I just add to that, it's like, when we were just getting Spruce off the ground, like what we kept hearing and to us continue to hear from engineers is that they're working incredibly long hours, like, mostly including their evenings and weekends, on top of all the kind of 9 to 5 stuff. But only some of that time is spent actually doing installations. And instead they're spending, this is the same for a small new installer as it is for a bigger installer that's kind of got a whole bigger team and that's trying to kind of grow faster. But they're, as a business, they're still spending a huge amount of their time like dealing with the tire kickers or with the inquiries that basically aren't going to turn into a real job anytime soon, like doing a lot of like slow manual processing of all the data that they collect around people's homes, like juggling kind of multiple disconnected tools, and kind of, copying, pasting stuff between them. And then, yeah, there's this big pile of paperwork that they've got to kind of put together, sort of throughout that process, which, is not what anyone really wants to be doing. And it's definitely not the best use of the kind of, the skilled engineers that we got.
So just talking about the paperwork. So do you do the DNO kind of things? And
Exactly. So yeah, actually, we're just getting to that this week and next, actually. So yeah, we're kind of now we'll start, help complete all of that other stuff that that the installers need to do. So to date, we've been doing everything up until the install actually starts, and then now we're starting to automatically complete everything else that they need. So like the DNO, notification, bus application, handover pack, MCS certificate, building regs, all that fun stuff, that is important.
That installers fucking hate very recently. One thing that's kind of cool, Nathan, or like that I found really like great at Spruce, is because we have like really close relationships with installers. We can, it's just like always evolving, right? So we like started out with something that people loved and helped them with a bit of the journey, which is this like initial estimate, like how do you get back to people with a reasonable kind of ballpark price. But then because we have these relationships and installers are really sort of happy to share their insights and pain points with us, we can kind of constantly be building the next thing to help them more. And the paperwork stuff really like fits into that bucket because it's just a massive pain point for people. So as Joe says, it's like we're working on it right now.
Because you've iterated, haven't you? So obviously I've known you guys longer than most, I suppose. But your initial kind of concept was to have something on like a widget. I'm getting a little bit technical for myself now, aren't I? I think they're called widgets. So like let's say I was an SME, I've got my own website which customers can come to. I would have something on my website that a customer could sort of click on, say I've got this type of house, it's this size, I've got this amount, and then that would give them kind of an estimate of what the heat demand of my home is, maybe a price. And I think that's what your initial thing was. But now you've obviously iterated into sort of developing more hands-on tools that the actual engineer would want as well. Is that right?
Yeah. So that they're like exactly like you say, we sort of started there, but now we're building out that end-to-end journey. So there's like one place where you do your heat pump job from that managing that initial inquiry, doing your heat loss survey, design proposal, and then the install itself, we're probably not helping with that much right now, but sort of starting to help with at least like the getting that installation team all the information that they need to do that job, like handing over well from that kind of pre-sales team to the install, and then all the paperwork, commissioning, and things that come off at the back of that. So very much as you say, it's like it's an evolving product as we kind of learn, I guess, what people need help with.
And Joseph, when you came into this, I mean, obviously you've had to dig really deep into what the paperwork is that these engineers have to do. So obviously, when people when they listen to the podcast or when they're just looking at social media or listening to people talking about heat pumps, probably people aren't aware of all this sort of bureaucratic stuff that engineers, and let's face it, they're engineers. They want to be getting on and fixing stuff or doing stuff or installing it. All this bureaucratic stuff that they have to do. Now, obviously, you've had to dig deep into that because you've got to code the systems that sort of do this. I mean, is your opinion that, or have you got an opinion that, perhaps engineers are being asked too much? Is there just too much bureaucracy in this whole heat pump game, or could it be streamlined? What are your thoughts on that?
Yeah, I mean, I guess what installers right now tell us that they feel they've got far too much bureaucracy, that they're spending far too much time doing paperwork. And so, yeah, it's definitely is like it's bleeding a bunch of time and ultimately money from their businesses, and it's not stuff that they enjoy doing, and it doesn't feel valuable to them. Which I guess is different from saying like, should there be no paper whatsoever? I think it's a kind of different thing, but it's like it's whilst it takes them ages and ages to do it, it feels like it's a really, really big burden. But I guess it's maybe people think about that a bit differently if it doesn't take you any time to actually go and put it all together, if it's all automatically done, maybe you don't mind it because it's sort of, you don't feel like you're having to spend another day or two even like putting it all together on every single job that you do. I think the big thing though that we think is, obviously lots of people talk about that we think is super important is this gradual move that is happening towards like measuring the actual quality of the install. Because I think there's a kind of, the other thing you hear from a lot of particularly really good engineers is that they feel like they're sort of doing a box ticking exercise and no one's actually kind of seeing how good a job they're actually doing. And you could have two installers. One could do a very, very average install with, very, very average SCOP and whatever else. And someone else could do a really brilliant one, but they kind of get the same marks in terms of, finding out the same paperwork in the same way. So I think that the more we can move towards something like that, the better it will be for everyone, I think.
And the mood music from MCS is in that direction. So we hear from installers that are like, excited about the idea that it's going to be more about delivered quality and less about kind of compliance and paperwork. But obviously there's still like a bunch of uncertainty about exactly what that's going to look like and when it's going to change.
Yeah, it was. It's been stalled a little bit, hasn't it? I mean, like you just alluded to, Joe. I mean, we still need the kind of paperwork. We need to know where these systems are going in. Your DNO applications have to exist. That makes sense that they exist. So they're kind of.
It does, just on the DNO, Nathan, to interrupt, it does make sense that the DNO application exists, although it is this like slightly funny imbalance because you can put in an electric shower without a DNO application, you can put in an induction hob, you can put in a hot tub. It's like specifically low carbon technologies must apply for DNO applications. And like I kind of get it, right? Like they're high powered things, but there is this like slight sense where it feels like this is specifically about hamstringing decarbonisation and like not other things. So I think we do need it, but it does feel a little bit strange that it only applies to low carbon technologies.
Yeah, I've put my fair share of electric showers in, Steph. back in
Right?
the day, I wouldn't want to do it now. I can't. But yeah, you're right. Now I'm trying to think. So I'm trying to think if someone's actually explained this because things like storage heaters as well. No one was doing DNA.
Right. Yeah.
When they were going, and they're bloody heavy to put in. Trust me. But I can't think if someone's actually so obviously with things like heat pumps, you've got this whole thing of, and this is beyond my technical knowledge. It like hertz and frequency is changing a little bit because of the way compressors work with how they take on electricity. And before I dig myself in a hole, I can't remember. It has
that's interesting. I thought it was just about that. It's like you're drawing a bunch more current, and maybe you're going to melt your cutout or melt the street's cutout. But like an EV charger doesn't have like something cyclical. So you're right. There's some like inductance impact of the
there's things like
heat pump,
harmonics and
but
things
like
this.
an EV charger doesn't have that, right? So.
I know nothing about EV chargers. So that's not
just
even a
like
topic.
pumps out a bunch of power, right? I mean, it's just like you're putting 7 kilowatts of power down a cable. I like to think of electricity like water because I only understand plumbing and not pipes and not fluid mechanics and not electronics. But
the flow. So this coming back to our old favourite topic of heat loss. You did a LinkedIn post the other day. I think it got alluded to on my most recent episode. So Tristan, them guys quite well, Tristan and Glenn. I think you might even be in their forum, I think. But they alluded to your post, really liked it. Lots of people really liked it. Just elucidate for my listeners what that post, give us the synopsis of that post. What were you trying to say?
Yeah, sure. I guess there's sort of two parts of it, really. One is, why is oversizing heat pumps bad? And then the second bit is, why is it happening all the time at the moment? Because it is happening all the time at the moment. It's bad for two reasons. The biggest one is that it blocks people getting heat pumps because you end up being told you need a bigger unit than you do need. At the high end, that means suddenly you're going from like a 12 kilowatt sort of standard single phase unit, and then like, oh, you need a cascade, or actually maybe you even need to upgrade to three phase power, expensive, a hassle. So like blocks lots of people getting heat pumps at the top end, or just means that they're paying a bit more for a unit that's too big. That I think is the biggest problem. Then also it is bad for performance. And I mean, like Glenn and Tristan were talking about on your podcast, different manufacturers handle cycling very differently, and oversizing is less of a problem with some than others because they modulate down better. But like on the whole, units that are too big cycle more and you get worse performance, and also probably shorter compressor life. So the compressor's going to break sooner. Although, it's kind of interesting to see as the data comes through on that. So that's why it matters. In terms of why it's happening, then I sort of went through and explained like where we see it happening, which is a few things. So firstly, this idea of what I called magic heat creation in the post. So if you are modeling rooms that are next to each other, you need to do a room by room heat loss because you need to size your emitters by room. But the sum of the heat loss of the rooms should be the same as the heat loss of the house. But in some tools, if you are looking at an individual room and you don't know what temperature it is on the other side of an internal wall, you think, oh, let's be safe and say it's 18 degrees on the other side of this wall. So my living room is losing some heat to my kitchen. And then when you're modeling your kitchen, you say, let's be safe and think that it's 3 degrees colder on the other side of this wall. And so my kitchen is losing some heat to my living room. So you end up with both of them. I don't know, they're losing like 100 watts to each other. Like, what? Like, where's that going? It's like going up the internal wall. Like, so that is a big one in cases where you're not like properly handling sort of how rooms are situated next to each other. And then beyond that, air change defaults being just wildly wrong. I mean, Tristan's done some great work on that, but they're just way too high, the default SIBSI values compared to what people find. Like people really find it's like somewhere between 0.5 and 1, and the SIBSI values are kind of go up to 2.5, even 4 if there's a chimney, which, as Jez said on that post, is like having just an open wall in the room. It's just like that's not real. And then there's some issues with some of the default U values, and kind of whether or not you're assuming that the neighbor's house is heated. So I think those are kind of broadly the reasons that people are oversizing.
And then I just add on that, there's a bit of a thing where I think we also see where the kind of system as a whole at the moment, it's like kind of incentivizes installers to oversize a bit. Like it's kind of, you basically get severely punished if you undersize a system, like which, because the house is not going to get warm, the people are cold, and so you might have to come and redo the whole system. That's all that cost is then borne by the installer. So there's a kind of, they're taking a lot of risk. So they kind of, there's then a bit of an incentive to then be cautious. But then, if you're then a little bit cautious in lots of different places, like Steph is saying, and then you're also on top of that, there's some of the systems that people might be using, or some of the data people might be using that's already making them more cautious than it might already be. Then that all kind of can compound together to mean that you end up being like substantially oversized. And that's kind of, that kind of feels safer for the installer, but it's like, but if that actually means that they win less jobs, like Steph was saying, because you end up quoting things that are too big that puts off more homeowners, or you end up installing systems that end up with poor efficiency and then and higher running costs, then it really does matter. So it's kind of, but it is pretty understandable as well why it does happen at the moment. It's just what we'd like to do is try and help people get closer towards that kind of towards right sizing the system.
So so your tools are going to try and help people to get more accurate sizes. But just going back to your point, Steph, because obviously you guys are very much involved in this whole estimate quoting thing. How much different is it for, let's say someone is having the next size up heat pump. I mean, how much more on the cost of that install will it be for a customer?
Yeah, great question. if this is like, is it the valent 5 kilowatt or the valent 7 kilowatt, or even like 3.5 versus 5? It's not that much. Like ballpark 500 quid to a grand. Um, the problem is at this tipping point when you've got like bigger houses where it's pushing you past that like 12 kilowatt, 14 kilowatt sort of top of the single phase, single unit range. That's when it really causes problems. And then the other thing is on rads. So like if you're overestimating heat loss by 50%, and then you're saying to someone like, oh, the only way we can get this room to run at 45-degree flow is by putting in a massive K3, then you're just going to get more customers getting cold feet than if you're like, do you know, actually, you can keep half your radiators. We're going to like put a few K2s in here and there, but like end up with something that isn't sort of aesthetically alarming. Um, it's just like that's much more attractive. So I think that's the other part of it. Not that radiators are particularly expensive, but just like in terms of the end result that people end up with and the level of disruption. I think that's pretty important.
It's more at this sort of this tipping point end, isn't it? That it can
I
be.
think the tipping point is the really important place, and because of like how much heat pumps cost right now, and sort of who's motivated to get heat pumps, lots of people with houses that are in that tipping point range are getting heat pumps, right? So like uh I'm actually my install is literally happening right now. I can hear them drilling in the background, and
Oh.
uh it's a 5 kilowatt unit, and like it wouldn't matter that much if uh
What manufacturer you gone for?
it's a Valen Aerotherm 5 kilowatt.
Ah, see, I thought you being you would have tested another particular amount. I mean,
Oh wow.
it's
Yeah.
interesting. So just before meeting you two lovely people and recording this podcast, I've just had a meeting with the EU Commission that all about ERP, which for anyone that doesn't know is energy related products. Because they listen to my podcast, very, very interested in the UK market, and they publish, and I'll be doing some links to it soon, but they obviously publish a database of all the different machines out there. And they, we were laughing because, you my family's been involved in the heat pump game a long, long time. That doesn't mean I'm an expert. I hate being called that, but yeah, and that's mainly air to air stuff. But what they were all saying, there's a lot more makes out there than the British UK engineers realise. The same two manufacturer makes always seem to come up. There's a lot more than that, and some of
Oh
them.
yeah, I mean we are aware of this because our installers ask us very often to add new products to Spruce. So we have like all of the product data is sort of preloaded on Spruce with like all the capacity data,
Oh, okay.
etc. So that we can sort of say like, okay, if your design outdoor temperature is -2.3 and you're designing at 35 flow, then you'll get this capacity or whatever. So that's all sort of preloaded in Spruce. And we do have a lot of products. I'm sure that there are more European products we don't have, and we will get asked to add them in due
Well, it
course.
makes
But
it makes it makes sense then actually, and both remind me because I've got a memory like Siv. I will hook you up with my friends at the commission because they want me to build a bit of a task force where they can ask people involved in the UK market what other extra information should manufacturers be providing, or what would be helpful if they did provide. I mean, as you will know from the Tristan sort of podcast we did, Tristan and Glenn, and a few posts around, people are asking for better sort of, they want to know what the compressors can do. Basically they want to know these
yeah,
minimum modulation rates. Some, people like Nebi and Steve will Eltron do it, provide it, but arguably some
yeah,
others don't. So that
yeah,
the commission are really interested. I mean, it's very interesting sort of that. I mean, they that route, because they wanted to ask my opinion. Do engineers know anything about ERP? And I said, of course they don't. Not really. I mean, because that, I think it came around I think in the UK, the trade media started to talk about it in about 2013, 2015. And it was all about, the problem was it was about products. And as we know, heating is a system. I opened up a speech about 7 years ago. Uh, everyone had. I was the last one to speak. There was a lot of people in this hall. I was behind the podium, and I could tell everyone was a bit bored. They'd seen the same PowerPoints, the same statistics. So I went up onto that podium and I said, "Right, anyone done the bleep test?" And most people are my age or above, and I'm thinking, crikey, half of them wouldn't have heard of the bleep test. And for my listeners, it's a fitness test, basically. It's a fitness test. And then it grabbed people's attention. They started not looking at their phones, they're looking at me, thinking, what on earth is this bloke talking about? And I then said, well, my brother is in the top percentile possible on the planet. And you now got people, and I knew what was going to be happening. People are looking at me, what is he on about? Right, right, right. And I said, my brother did his bleep test at the SAS camp in Hereford. Now, you mention SAS in this country, it gets everyone's attention big time. And I don't like lying to people. So I immediately said, look, my brother wasn't in the SAS. He just happened to be signed up for Hereford United when he left school to play professional football. And they did their pre-fitness training with the SAS, blah, 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 blah. But I've captured everyone's attention. So I then go on to say, my brother's got a super duper efficient heart. You know, he's got a VO2 max of 63, even at 48. He's super, super fit. And then I stand out from the podium. I say, if you were to transplant his super duper efficient energy rated heart into my body, my system, I ain't going to run any faster. Because look at me. And I'm quite an overweight gentleman. And then people get it. It's not about this A+++ ERP rated board. It's the system that makes something efficient. And they did back in the day. So they've got these they're called packaged labels. So rather than just labeling up the actual appliance, there is a package label, and this is what they're very interested in. So they're obviously watching me, what I talk about, and they're watching the people at the open energy monitor, heat pump monitor, because you know it is about a system. It's not just about a product. So there is a lot of interest from them. There's also a lot of interest about onboard monitoring. But like I said, that is extremely, extremely problematic. I mean, they've got something called, I think there's something called the Net Zero Industry Act. They mentioned to me now, whether that's something to do with it or not, I can't remember. But you know, the whole thing of having matched pair temperature sensors inside everyone's unit, and also metering. You know, electric metering, proper electric metering inside the unit is probably going to be a bit of an issue. So I don't know. That's not anytime soon. But the conversations are happening.
Just to come back to the system, system not product thing, Nathan, I think like that's spot on, and I guess what we try and make what's nice about having a software product is you can make that clear, because yes, we've got all this data about the Viessmann and the Veneratherm and whatever host of products, and yeah, you can go in Spruce and you can look at all the capacity data and how it changes with air temperature and flow temperature, but you can also surface okay, with these radiators that you've designed and this flow temperature, what does the performance look like? And you can translate that into SCOP and into bills. And obviously that's all modeled, but it's much easier to show the installer and then the homeowner what all that stuff means in the system design, rather than okay, I can send you a data sheet and Glenn and Tristan they're gonna pour over that data sheet, and that's great, and a bunch of engineers are gonna pour over that data sheet, but lots of people aren't, and so trying to make clear with this system, this heat pump in this system, this is the performance you get. We can sort of surface that to people, which I think is just illuminating and clearer.
Joseph, one thing I do want to know, and I must have asked you, we had a lovely dinner not so long ago, didn't we, together? But why are you called Spruce? Where did that name? I love trees, so I'd like to know where that name come from.
Yeah, I think you get bonus points for knowing that spruce is a tree. I think when we were at the installer show back in June or whatever it is, we had a spruce tree on the stand, which we thought was kind of obvious as to why we had it. And then we had a lot of our customers coming up and going, why on earth you got a Christmas tree? It's June, what's going on? But yeah, no, I mean, it was actually my sister that came up with the name originally. Why Spruce? I mean, yeah, it's combination of
evergreen.
It's green, it's evergreen, and we're kind of helping trying to do our little bit in helping people spruce up their homes.
I've got my spruce jumper, haven't I? I'm quite proud of my spruce jumper.
Yeah,
they're great. Joe's a great clothing designer as well as running a heat pump company.
It's the backup business. Yeah.
Yes, Alex Winters at LibTech had no idea that a spruce was a tree, so He
Bless
gave
him.
us some feedback that maybe that wasn't clear enough.
Oh, he was a great
Um,
engineer. I chat to Alex.
he's fantastic. He's
Oh,
absolutely fantastic.
I
Yeah.
will rib him though that he didn't know that was a tree.
Oh, I know. I feel bad saying that. No, but like at least that's on us.
I
Uh,
think he actually shared that himself on a LinkedIn post
oh, he
recently.
did.
So I think
He
I think
did.
we're safe there to bully him for it. Yeah,
But
yeah.
he's a different
He's
generation.
he's a champ.
Maybe,
He's really great.
maybe. I mean, I'm twice his age. Maybe people don't. I mean, I make my daughter go up and say hello to trees. And she now makes her nephew because my stepson's 27, but so she makes her nephews too. We all go up to these big trees in our park and say hello to them and have a little chat. I mean, people think I'm strange there, but when you look at some of the trees, so we live near a very lovely local park that's got trees in it that are 6, 7, 800 years old. The things them trees, the history that they've been around is it's just amazing. It amazes me. And obviously the yew trees, which are evergreen tree in this country, the yew trees are really, really old in this country.
Yeah, wildly so. Yeah, definitely.
Yeah, apparently there's a yew tree that's over 2,000 years old. Yeah, it was here when the Romans were here, in this country. So let's get back to heat loss before we start talking about trees. What else is on the agenda? What are you sort of looking or hoping to achieve in sort of the next few months? As well, we're in winter now, so is there anything sort of that's are you looking for any signals as we're going through this winter period?
Uh, I think, I mean, probably less so for us than for installers and maybe for other people working more on the kind of grid flexibility side of things. But yeah, I guess so. We're starting to work a bit more now with some of the kind of suppliers and merchants and manufacturers. So trying to kind of basically help them with some of the same stuff that we're helping the installers with, kind of connecting them together a bit. So there's quite a lot of stuff going on there. And to be honest, though, the list of things to do that we've got on our roadmap is just growing at a slightly terrifying rate. I mean, it's exciting too, but ultimately pretty terrifying. But it's cool because it's all stuff that installers that are using us at the moment are telling us the whole time. We're speaking to them every day. We've got lots of messages flying in of, oh, could you add this, or could we do this, or what about in this case, or can I do this kind of thing too? So yeah, I think there's a lot of work ahead. Do you know what I mean? Just to kind of make it work really, really well for every kind of business with each with their own different process. People who might do other sorts of products alongside, all that kind of stuff. So it's yeah, we're gonna be busy for a long time yet.
What
We're in
differentiates
this.
you? What differentiates you? Because obviously, I'm quite well known in the industry, and I know that there's lots and lots of players and startups that have come in and kind of doing very similar stuff to you. They know me all very well. So, I mean, what sort of differentiates you? I hear good things about you. Obviously, I know a lot of the engineers that are using you, but what sort of differentiates you? What would you say is your main differentiator?
Yeah,
Yeah,
I think.
oh, sorry, Steph,
Oh,
you go.
go on.
Yeah, no,
All
you
right.
go, Steph.
Um, I think. I guess what we see in here is there's lots of different and like excellent products out there that help installers with different like parts of the journey. Um, but people find that they end up sort of copy pasting a lot from one thing to another. So they do a little bit here and a little bit there, and for each like category, that product works really well. But then things end up a bit scattered, and it's sort of hard to keep track. And so I think what's sort of different about what we do is that we're putting like everything is in one place, and so that data flows through from that beginning to the end of that journey. And so just like sort of centralizing, trying to put everything in one place and stop this copy paste thing, I guess is the big difference.
Yeah, that's definitely spot on. That's definitely the biggest thing. I think just actually talking to a few people about it this week. I think the other thing that the sort of installers like is the fact that we're moving very quickly. So we kind of, basically everything that we built this year. So there's always more and more stuff coming out. And we build everything with the installers very much involved in it. So kind of, we decide what to build based upon what people are asking us for. We do little designs of how we think it should work, and then we get their feedback on that kind of, before we actually go and build it, to make sure that it's kind of, is this what you mean? We think this could work like this, and this? Would that solve it for you? and then we release it, get them, they start using it, and then we're very responsive to the feedback. So they go, oh yeah, actually I like that, but oh, can I now do this bit as well? Or actually, yeah, I did say that, but actually I realized there's a different situation where I want it to work slightly differently. So like the fact that it's like
Tell us what we
continuously
did wrong.
exactly, yeah, but like continuously iterating like really, really quickly on it. I think yeah, they like that a lot, I think, because it means that, well, it's helpful for us because it means we build the right stuff. But it also means that it really does very specifically solve the problems that people have. And it's not us kind of, I don't know, I mean, sitting in a dark room, kind of imagining what we think the ideal outcome would look like, and then bringing it to installers later, and then saying, here's the product, do you want to use it? It's kind of, they're fully involved in that process.
You've done well. I'm trying to remember, Joe. Were you part of the Carbon 13 thing, or have I got that wrong?
I wasn't actually, no.
No.
But I think a lot of good people have done that, yeah.
Yeah, I speak to so many people, and I forget who was part of that and who wasn't. Now, I think I mentioned Steph when I was mentioned you in the last previous podcast. That you know a bit about measuring heat loss as well, and as you know, it's something I've talked about in the past as well. What are your thoughts around that? Obviously, we've got a lot of tools out there that engineers can use to sort of calculate heat loss. Obviously, like yourselves, they're getting better and better. You're really sort of digging deep in how to make them better and less challenging for the engineer. What are your thoughts around measurement and how that can integrate, maybe, or where do you see
Yeah,
that?
I think measured heat loss is fantastic when you can do it. Like, even with like however easy you make heat loss and however good you get your assumptions, like unknowns will remain about exactly how well the cavity's filled or where or what the block is and all that kind of thing. So measured heat loss is fantastic as a way of like reducing that uncertainty. And also as like a validator or sort of touch point to kind of compare against. The problem is that it's slow and costs money, and so I think it's like cool when installers can do it, but I think it's a bit impractical to say like, oh, that's all we should do. So like, yeah, I'm super pro measuring heat loss, I guess, but I just don't think it's like uh, a fast enough solution to sort of be the one and only solution. And also you can't do rad sizing off it. So um it it's great and adds loads of value, but doesn't totally solve the problem, I think.
So when you mentioned the rad, so you're talking about sort of individual heat losses, aren't you? I suppose.
Yeah, exactly. Because like like as you say, the system, like it's the system that matters, and like the system, like that's all about the emitters, right? And so you need to know emitters wise what to put where.
I guess the other thing I'd also add to that is like, there's a lot of different ways in which you can measure stuff. And there's a lot of people kind of coming up with increasingly innovative ways of doing it. But some of the things that people have used historically there are kind of, getting data from smart meters or kind of actual energy use, those kind of things as a way of either checking or kind of, using that as a way of using that data as a way of doing the overall heat loss. Which has some of the challenges that Steph has already mentioned around like not letting you do emitter sizing. It can also, again, depending on how you're measuring it, end up being a bit misleading because you can end up measuring kind of, well, yeah, if you've got a small number of people, you've got a couple of people living in a really big house, you can end up kind of looking at kind of basically, the way they're consuming heat in that home might not be how the next people who live in that home would end up doing it. So yeah, I guess it depends how you go about doing that, whether you've got sensors in every room, whether you've got some of these sort of clever TRVs that people are starting to do, or whether you're kind of trying to measure it based on kind of aggregate data.
Steph laughed when you mentioned TRVs because you probably have an opinion on them.
One thing I am really excited about here though, Nathan, is the like feedback, like learning, like whether we can start getting monitored data and like integrate with some open energy monitor and like other monitoring systems and like bring that into Spruce to help people learn. So like, have I oversized? Like, I mean, Glenn and Tristan have done amazing work on this already, but like trying to make it really clear to people, like so that they can learn from the installs they've done. As like, okay, your calculated heat loss was 10.2 kilowatts, so you put in a 12 kilowatt unit. Actually from monitored data at -3, this house is losing 6.5 kilowatts, and like like trying to sort of close that loop a bit and sort of help people see and learn what they're doing, and almost then you're like refining your inputs to the heat loss calc. So it's not about using the measured data to size your kit, but it's about learning from the measured data to do a better job of that system design in the first place.
Yeah, I like that. I mean,
We haven't done it yet, but we're going to do it.
I mean, it's such an interest. This whole thing of heat loss is captured the attention of lots of people. So I, I always try and remain polite on my social media, but I do get myself, well, I seem to get myself, I've got myself in trouble today. E3G aren't happy with me and don't want me to tag them in posts because, I didn't think, but there's Kestrix. I don't know if you've heard of Kestrix. So there is about 3 companies that are doing thermal imaging, and 2 of them have contacted me. They do sort of they go drive around in the car like the Google cars used to. They take photographs of homes and thermal image them. And then you've got aerial thermography, which is what this Kestrix doing. And yes, they got some extremely clever people in that startup. I mean, they got an ex-Google, high up Google person. I really like their mission of scalability. If you can scale this the whole of our country very quickly and say, right, this. But I did point out to them because they did want to come on the podcast, and then I said, well, you're not quite getting it there. You're not quite determining heat loss yet because you need to know the internal temperature. I don't care what anyone says. That's the laws of thermodynamics. You need to know that internal temperature. And I use the analogy for my listeners. So this is the analogy I use. Every year, we'll get it this year. As soon as snow starts to happen, we will get it. You'll get people post up on social media a picture of 2 houses, next door neighbours. One will have snow on the roof and one won't. And they'll say, oh, look, you can tell who's got the insulation in their loft. And I always go back and say, no, you can't. You can't tell that at all unless you know the internal temperature. Because the house without the snow, which is what everyone assumes hasn't got insulation, could have old people living in it. They get up at 5 every morning because some old people like to get up early. They whack that heating on. They whack it up to 24, and that snow starts to. They've got good insulation in the roof, but the snow starts to melt. Whereas the person next door with the snow on the roof isn't there. Or they commute. They get up at 5, they go to work, and they don't turn their heating on till they get back home from work, or they're actually not there unless you know the temperature inside that home. So I did say to Keswick, you kind of need to know that temperature inside your home. So now don't get me wrong, they got the best AI people on the planet, I suppose, that they will start to make some inferences. They might be able to make some sort of really good assumptions, but you're still assuming. So there are going to be some properties where you just don't know.
Yeah, and I think that's what Joe's saying here about like if you take some data out of context and you run some nice machine learning model on the smart meter data, there is a bunch of stuff you just cannot know about how that home is being run. And if you do that, and there are people who wear 5 jumpers inside and keep the home at 17 degrees, and you size off that without knowing that and without having sort of agreed that with the customer, then you're going to make mistakes. So I think you do need that information. You can't just be like, I'm a data boffin and I can do it from far away.
Would smart meter data help you guys with any of your tools?
Yeah, so I think you can. I think it's like a yes and, right? Like if you use smart meter data to calculate the HTC of the building and you compare that with what you get from a heat loss calculation, I think there is a really interesting insight there. You can do that comparison. And I mean, we already do it a bit, like we let installers enter consumption data and compare what that gives in terms of sort of an approximate heat loss, like with like the HDD stuff. And you can already sort of start saying to people, oh, well, like based on what you've calculated and the heating degree days versus what their consumption is, like either that they're pretty close and like you're probably quite right here, or actually you're really far off. Like, have you missed a bunch of windows, or have you actually used a view value that's completely wrong, or are you being way too conservative on air changes? Probably yes. So I think already with like quite straightforward consumption data, you can do that. But yes, with smart meter data, you could do a better job of that because you can get it you can kind of correlate it with what the temperatures are outside and do a better job of that HTC calculation.
Yeah, but context is the key thing there. It's got to be that alongside the context of everything else. Just not by itself. I think just Nathan, just the other thing just on because on gastrics, I think that thermography though, it feels like there's a valuable thing there. I guess I don't know whether that particular business is trying to do stuff around like sizing heat pumps, but obviously if you do know some stuff about what's going on inside the home, the thermography can be really useful for identifying areas where insulation might have slipped and or kind of if realizing that if you've got a whole set of properties in a social housing development that like maybe some of them have less roof insulation than others or got missed previously. I don't know, there's kind of like, there's a whole bunch of other stuff that does do, but yeah, so
like building performance gap stuff.
Yeah, there's some amazing stuff. I mean, like things like shading. You'll be able to see what homes have got shading, which helps for keeping cool in the summer and knowing which ones are more appropriate for maybe PV. That can do some amazing things. It was just the whole thing around heat loss, because I suppose they know that heat loss is a bit of a big topic, so maybe they were just trying to capture attention for their startup with using it. I mean, they might get it in the future, but yeah, there's some definitely makes a lot of sense. It definitely makes sense to be sending drones up and doing this stuff without a doubt, and thermography without a doubt it makes sense. And with the clever people they've got, and they've got a lot of funding. I mean, they've got £500,000 in funding. So yeah, I mean, wish the best of luck to them, and they probably will come on the podcast at some point. But it's all it's all about assessing our homes properly. As we know, we've got this EPC consultation coming on. I'm sure you guys are going to be right involved in that, because this is the stuff. I mean, you work with EPC data, I suppose, for your algorithms are working with that data. I mean, what are your thoughts around that, you two?
Yeah, it's great that it is available, right? Like it is a super helpful starting point to have that EPC data, that description of the home. The problem, as I'm sure you and lots of your listeners know, is it depends on how good the domestic energy assessor who filled in those data points was, and lots of them are excellent and do a great job. But that's also like it depends on the context that was done, and are they getting paid 20 quid and they're doing it from outside because they're in a massive rush, like anything. It's like, but so I guess number one thing, it's just fantastic that data is there and like available. It's super helpful for us and for many other people in terms of like a starting point. What is this house made of? Does it have a suspended floor? What are the walls? All that kind of thing is really great. So that's the sort of data inputs. And then there's the model, like the SAP model, and it's moving to the home energy model. Lots of that is actually fine. People love taking taking a shot at it. Lots of that SAP calculation is actually very reasonable. The problem is at the very end, the way it kind of gets transferred into the rating. So there's a bunch of stuff people like misunderstand, right? So like an EPC is about affordability. It is not in any way about carbon, and people just like totally miss that. They think of it about being about greenness, like, oh, it's EPC, it's green, but it's actually about affordability.
Right.
But then the problem is that affordability thing is wrong because the SAP calc is using tariffs that are just like massively out of date, right? Like energy prices have changed quite a lot in the last 5 years because global events have meant that they've had to. And so that's like the problem. And I was actually just reading that consultation, and they acknowledge exactly that problem. And it is quite a hard problem, I think. How do you give people like a reasonable sense of the affordability of keeping a home, of living in a home, and the carbon part in a way that is comparable? I don't think it's straightforward, but for sure there's some problems.
The other thing I did, pick up on one of the things, particularly that Steph was saying there, which is like, I think if you can get better data being collected as standard, that's going to, people, that's part of what the changes are going to be about. It's not the only thing. There's a bunch of other stuff that Steph's referring to there as well. But if you can get better data, then that's, everyone can benefit more from that. But you do have this problem, well, not a problem, but you do then also need to then make sure that people are sort of incentivized to spend the time collecting all the data that you need and so it basically is then useful because we've basically got used to with EPCs. But EPCs are basically when people basically sell or rent a house, and what do you pay for an EPC? You probably get an EPC done for like 70, 80 quid, can't you? And like that's including their time to do it, to write it up, to travel. Like that doesn't give anyone very much time actually there. So I think there would also, if we are going to expect those energy assessors, the people who are going to be doing it, to actually go and give us all better data, and then put through a better model and present the results in a better way, and and everything else downstream of that. You've also got to sort of understand it's going to cost more every time we do that, so that we can then trust the data that's coming into those models as well.
And that's just where that whole thing of Kestrix comes in. Scalability of data is really important, isn't it? Because sending lots and lots of people into homes is actually quite problematic and costly, isn't it?
Well, on the other hand, then you do then I think it, like, for a heat pump survey, you send someone into the home. When you're selling a house, you send a surveyor into the home. So it's almost more like, how can you collect that data and collect that data well fewer times, rather than loads of people go in and take the set, like measure up your rooms for different reasons.
In Scotland, I think that's done. I think in Scotland, when you sell your house, that you have to have someone go in and build up a home information pack.
Okay, and it's like more widely shared.
Yeah, I know the company that sort of does most of the homes in Scotland. I'm just trying to rack my brain to think if I've got that right. So yeah, I think if you sell a home in Scotland, you have to have it assessed. I'll find out for you a bit more than you would do in England.
Okay.
I think we had the home information pack thing way back, and then it sort of got dropped from.
Okay.
Yeah, someone will
Yeah,
fact check me and tell me if
yeah.
I'm right on that. But go. I want to just talk, because obviously we know you from when you come on the podcast last. You just got back from Canada, and you were sort of sizing big stuff over there, weren't you? The Canadians, I mean, obviously they're working to much lower design temperatures for a start, as you know. But do they have a similar U value system? I mean, have they got? Are they using an international U value system, or have they got their own? I mean, obviously a lot of our U values come from people like BRE, then gets published by SIBSI. Yes, you have got hot boxes around Europe sort of testing some of this stuff, but then you've also got people like BRE going out and actually measuring this stuff, and then they will put. So with the solid walls, for instance, I think 300 solid walls got
Yeah.
got
Yeah.
measured. Every single solid wall was completely different to each other, measured
Yeah.
with flux plates and all this technology, wonderful technology. So they have to pick an average. So that average they pick that we all get in our U value tables might be on one day with one property spot on, but it could be completely out for another property.
It's not spot on for that many. I mean,
No,
it's
it's not.
2.11, the one we get, and what they measured on average was 1.5. So
Yeah.
it's 25% error right there. But
What's the system the Canadians use?
um I mean, like, obviously the maths is the same. The way that you, like,
Yeah.
what a U value is, what's for me is square Kelvin, but the buildings are all way newer. So like it's just, you just don't have this, like,
Right.
that's 300 years old and who knows what aggregate is in this wall, right? Like it's just much easier to be like, it was built at this time. There's still a bit uncertainty, but it's just it's much more straightforward. Also, they're all like, it's mostly all timber frame. They don't use masonry building at all. Like, there's so much wood. It's all timber frame. So in a way, there is much less uncertainty around that. But then, I mean, as you point out, the challenge then is that your design outdoor temperature is minus 23. That changes things quite a bit.
Is that the average across the country, or is it like ours? You get slightly different ones because it's it's the second biggest country in the world.
Much more different. Yeah. So that's Quebec, Montreal, where I was.
Yeah.
In Vancouver, it would be like -3. Vancouver's like here, really. But then in the mid Calgary, like the central Canada, like -40.
Wow.
So yeah. And so what's different there, right, is that you are not sizing heat pump 100% output at design outdoor temperature. You're sizing at, like, so in Montreal we would size at -15, and then you put in electric backup, but it runs in parallel with the heat pump. So it boosts. So the heat pump does, I don't know, like a DT of 3, and then the electric backup boosts that I mean, this is all air, but it takes the air temperature to be slightly higher. And so actually, even though that heat pump might be sized at like 70% of output power, it's doing like 90% of the energy, 90% of the heat kilowatt hours are from the heat pump, because that electric backup is running in parallel with the heat pump. Which, if you have to switch the heat pump off and just the backup totally take over, then you get much worse, like a much worse ratio there. And it's sort of one of my worries with all this hybrid stuff, is that the gas boiler will take over from the heat pump, and so you won't get that nice ratio that you do if the two things run together.
Go on, talk about hybrid, Steph. Go for it, because hybrid is interesting. So there is. What am I allowed to say? So let's say, for instance, on the Heat Pump Association, there's a particular manufacturer that is really, really pro-hybrid. I'm not going to say they are. Now, what are your thoughts on hybrid?
This is probably a point where we differ slightly, so let me say what I think, and then also give Joe some space. I think there's probably a place, but my big, I guess I have a practical worry that two things. You put in a system that is more complex than a heat pump. So like an all electric, just the heat pump. You have to handle all of that, and you have to put in the gas boiler, keep your gas connection, and then work out all the plumbing so that all works seamlessly together. So in the same way that a hybrid vehicle is more complicated than an electric vehicle, a hybrid heating system is more complicated than an all-electric heat pump-based heating system. And then the other thing is just, if you get the controls wrong, the gas boiler will just run all the time, or loads of the time. And so you're going to this extra effort, expense, maybe government money, I don't know, to end up with a system that doesn't actually decarbonize very much, because you just run your gas boiler. And so that's my kind of concern, I guess, is that just like practically that won't work.
Same concerns as mine, exactly the same concerns as mine. I think they're getting a bit overplayed. Yeah, everyone uses this term, oh, there's no silver bullet. No, well, of course, yeah, we know that. Tell me something new. There never has been. There's always been all sorts of ways of doing things in this industry. I think when people use this term, there's no silver bullet, what they're basically saying is, look, we've got a product, we need to sell it to maintain our market, and that's the best soundbite we can come up with.
I mean, I'm going to put it out there. I think there is a silver bullet, more or less, and it's heat pumps. Like, people say that when they're like infrared heating, oh, it's infrared heating, heat pumps aren't a silver bullet. Like, sure, there are some exceptions, but like heat pumps are fucking magical, right? They use zero carbon energy, and they have an amazing efficiency. And
it's the most overused term. I mean, I feel sorry for people sometimes, because it's definitely not personal, but the Liquid Gas UK did their thing at Westminster in front of MPs, where they announced their their report, which was written by GemServe. GemServe write reports for anyone that wants a report. They'll write one for, whether it's hydrogen, heat pumps, or whatever. And they wrote this report, and it never mentioned once air-to-air technology. So basically, the report's saying it's very hard to heat rural homes with heat pump technology, or it's costly. Yeah, it can be with a hydronic system, but there are air-to-air systems. They've existed long before natural gas boilers. And they delivered that report in a marquee. You don't get more leaky than marquee, with a heat pump over the head of the person speaking at the lectern. And this is the bizarreness of this industry. You've got so many people talking about it now who actually, if I'm honest, don't know what they're talking about. They don't know what the technology is that's out there. They don't know the systems. And the comeback from me was that, oh, yeah, but there's no silver bullet, Nathan. And I'm thinking, oh, God, here we go again. No, there's not. But there's a few bullets you actually don't understand should be in your holster. You completely forgot about air-to-air. It's a very, very overused term now, I think. Joey, better let you speak for a little bit. Go on, before we.
No, I mean, no, look, as in, I agree with everything you're both saying. Like, Steph and I very strongly agree on that. I guess I'm probably maybe naively a bit more optimistic, or I think that, like, in theory, there are benefits to hybrids. But yeah, there's a load of practical concerns about how if we do suddenly start doing them at scale, like how that actually happens, and are they done well? I think there is a lot of risk that it ends up not being done well, or at least frequently not being done well. But I think so speaking more theoretically, then, like, at one level, it's comforting for a homeowner, So
Without
particularly a country like the UK, where people like still, your average person is still pretty unfamiliar with a heat pump, that, you can tell them it's been around, the technology's been around forever, but it's kind of, for them, it feels a bit scary and new. And knowing that you've got a backup, whether that's a fossil fuel backup or an electric backup, I think is comforting. And so I think that might mean that more people are more willing. They feel like they're taking less of a risk. And I think there's, again, speaking a bit theoretically, I think it also could mean that you end up with so that would help more heat pumps go in. And then the other way that it could help more heat pumps go in is that it means that you can get away with doing fewer like emitter changes up front. Again, if you're assuming it's all designed well, you can basically say, look, the heat pump will support you down to, I don't know, call it 0 degrees, and then anything below that will get the backup will kick in. And as a result of that means that you can keep, I don't know, 90% of your existing rads. And so that then reduces the upfront cost, or reduce the upfront cost of the emitter changes. PBC, what the overall cost then looks like, or that will, whatever the grant ends up being will have a big impact on that. But it reduces the upfront cost of the emitter changes, reduces the disruption, which obviously is a blocker for homeowners. They go, oh, I like this idea, but I don't want someone coming in and having to, rip out my rads and change everything in every room. I've just got it painted or whatever it is. So I think that there's stuff around it that could be positive, and I think that it could be a really good thing. And I think there are some countries, I think like the Netherlands, I think I'm right in saying that they have hybrids are very, very popular. If not, I think the majority of installations that go in are hybrid, and that seems to have, it's one of the factors I think that's helped, high heat pump uptake there.
Yeah,
but as you're both saying, it's got to be done well, and I think there's a really high chance that if it's handled badly, we make the whole situation worse for the whole industry, basically.
Yeah, we had a great guest come on, a friend of mine, Christoph, who discussed how it can attenuate the fear for a homeowner, because a lot of homeowners understand we're going to have this fear, will a heat pump heat my home? So it mitigates that fear because they've still got their boiler. And if it is done properly, that boiler's going to hardly be on. So he made a really, really good case, and he had four. There was 4 points to his case. Can't remember them now, but yeah, no. So for the homeowner, there can be some common sense. And yes, you're right. In the Netherlands, they kind of had that sort of strategy going on. I don't know how prevalent it is now. I'll find out. What is the consumer? Obviously, when you first started building your software, it was for engineers and helping the engineers. Is there a consumer element to it, a consumer facing element to it? Well, actually, they do interact with it, the first initial piece of it, don't they? I think.
Yeah, exactly. I think we're building for installers, for engineers, and maybe a bit for the suppliers and manufacturers when they kind of want to, basically it's helping them interact and work and support the engineers. So it's all centered around them. So that's who we kind of really care about. That's who we're building for. That's who we really listen to. That being said, the homeowner is a pretty important person here. That's ultimately who's getting the kit. That's the homeowner that really matters for the installer. So yeah, the homeowner interacts with Spruce when at various different points. Like they might be putting in some information at the beginning. The reports that we get, that we help generate, or the proposals that we generate on behalf of the installer, kind of in their branding and stuff, are all designed to be consumed by homeowners. So we spend a lot of time with homeowners, trying to make sure that what we sort of put together on behalf of installers is really clear, easy to understand, so that they kind of, they aren't worried about it. They kind of are almost like handheld through what can be quite a confusing dump of information, which is sometimes the thing that the homeowners feel they get when they get this, whatever it is, a 30-page set of reports, and they're like, what am I meant to be looking at? How am I meant to understand this? By throwing lots of data at me, does that mean that I'm meant to then just trust you? So yeah, they're really, really important, but they're important for us insofar as that's the installer's business, is working for them. So the more that we can make, we can help improve their interactions, or do our little bit to improve their interactions, then that really makes a difference. And then the final thing there is I think the more macro thing, one of the bigger things that we find that we're able to do for installers is, because we can free up so much of their time, they're able to then spend more time with homeowners. So they're able, and there is a lot of education and hand holding required, and installers do like a phenomenal job of that. But when installers are completely rushed off their feet and got inquiries coming in from all different directions, historically it's meant that they have had less time than they would have liked to spend with each homeowner. And obviously, if they can spend that little bit more time, that's obviously good for the homeowner, but it's good for the installer's business as well, because it means they ultimately get more people to take heat pumps. They win more of the jobs win more jobs than they would have done otherwise.
Mm. You guys are at the development level where you can take on lots of installers, as many installers now, aren't you? Yeah, yeah.
Yeah, we got a lot. Yeah, and they seem to be coming in thick and fast, which is really nice because we sort of haven't done very much, marketing type stuff. So we actually did, but yeah, the installers that we're signing up are coming in because they've been referred to by other installers. Either people have said, passed it over on a one-to-one basis, or
Yeah.
we get posted about in groups and forums and stuff. So we like that because it means that the nice things that we hear from the installers, they're not just saying to be nice to us. They kind of, at least some of them clearly do really mean it.
Yes, that peer-to-peer learning I talk about, isn't it? And peer-to-peer information. Yeah,
Exactly.
it works. Well, it's been before we go though, Jaz. I have asked you this before as well. And this is how rubbish my memory is. What were you involved in before you got into this industry? So, what were you? Were you techie? Were you in software? What were you doing?
Yeah, I was working in a very different world, really different space, but it was very much software. So I was basically running a different software business in a completely different world, but it was kind of still had like data at its heart. So I guess that's kind of similar, and it was around like helping improve, using data to help improve people's systems and processes. And then basically, just been interested in heat pumps for a very long time. Like my parents had tried to get one, some friends had tried to get one and had bad experiences, which sort of intrigued me as to kind of what that seemed to be, at least for some people, we're getting poor experiences. But it was only when I actually started talking to installers, like kind of that I realized that was basically where that's where the problems lay. Like not the installers themselves, obviously, but the process that they were having to go through. And it was also became very, very clear that a lot of installers feel that people just weren't listening to them, that there's a lot of policy stuff going on, there's a lot of kind of chatter in a lot of different directions, but installers are weirdly seem, I think it's beginning to change a bit, but historically at least installers were kind of got missed in some kind of way. Like the kind of people just didn't seem to pay proper attention to what they were saying, the frustrations they had, what they really needed, despite the installers, the engineers being clearly so important, so entirely central to what everyone else is saying they want to do, which is encourage and accelerate the uptake of heat pumps. So yeah, that was the bit where I was like, that's the problem we want to go and solve. Those are the people we want to go and solve it for.
Steph, I want to ask you, do I know you're installed? Because you're, like you said, you're currently having a heat pump installed at the moment. Would I know your installer?
Yeah, it's Fred Rickman.
Oh, right, okay. Yeah. Oh,
Yeah,
brilliant.
I love delightful team. Really, really nice. Yeah, I mean, it's been super fun to see it really happen.
So you're going to be over Christmas, if you're spending Christmas at your home and not sort of traveling anywhere else, you're going to be nice and warm, being kept warm with vapor compression technology.
Yeah, exactly. I am. Yeah, the whole team are gonna come over and admire it once it's all done, and it's gonna be on Open Energy Monitor. So I'm excited to dig into geek out on all the details there.
Oh, brilliant. Well, it's been a pleasure having you both on the podcast. Thank you ever so much for coming on.
No, thank you so
Thank
much.
you
It's
so
been
much for having us, Nathan.
definitely our
Really
pleasure. Yeah.
enjoyed it.
Super duper. And I'm sure I will catch up with you in the not too distant future. Thanks a lot, guys.
Cheers.
Lovely.